About 250 kilohertz. If the speed of the wave is 3.0 times 10 to the power speed of light. Calculate its wavelength. That's simple question. So 3 times 10 to the power 8 on 250 times 10 to the power 3 hertz. So we have 3 times 10 to the power 4. This must even be 4. Okay. 1, 2. So 3 divided by 2.5. So we have 3 on 2.5 times 10 to the power 3. Then the second question. The displacement of a plane progressive wave is given by the equation this. So the displacement equation is y is equal to 10.5 sine of 120 pi t minus 0.5 minus 0.5 pi x. This is a displacement equation. You have to calculate x and y are in meters, whereas t is in seconds. Calculate frequency, wavelength, speed of the wave. So calculate frequency. So omega is equal to 125 t. Therefore, 2 pi f equals 120 pi t. Okay, 2 pi, this is 60. Okay, therefore f is equal to 60 hertz. Then wavelength. For wavelength, 2 pi on lambda is equal to 0.5 pi. Pi lambda will be equal to 4. 2 divided by 0.5, 4. Then the speed, since V is equal to F lambda, frequency is 60, lambda is 4. So 240 meters per second. So easy. And this is the kind of question which came under waves. And there are a lot of simple questions. So, in fact, attaining A in WASI is achievable. Okay, let's continue working hard, solving questions, and it's gonna work out to our benefit. Please, any question? Any question? No question. Ask your colleagues to join. Oh. Let's solve the set of questions I gave you. Yes, some of you got a spot on. Priscilla. Priscilla, go ahead.
Good morning.
Good morning, Priscilla.
When I started, the question was already given, so I didn't get the question.
Don't worry. It's one of the NOVDEC questions. Okay, so you'll get it. Right? All right, so the first question says that they have open to the now deck. All right, so a wave traveling in the positive x direction with amplitude 0.2. So the amplitude of the wave 0.2, then has a velocity. The velocity of the wave is 360 meters per second. The wavelength is equal to 60. Hello. Hello, Charlotte. Then the speed, then the equation of the wave. The equation of the wave. So this question, okay, seeks to demands the equation of the progressive wave when you are given amplitude, velocity, and wavelength. Here, in fact, a lot of you did very well. I must actually commend your effort. Some of you derived it in terms of velocity, since velocity and wavelength are given. So if you want to derive it using velocity, the general progressive wave equation, it is moving towards the positive x-axis. So A sine omega t minus kx. Okay. Some of you were writing kx before omega t. Please, when you do that, note that then it will be minus kx plus omega t. And if there's no need writing it as such. If you can just write the simple thing and go continue. Okay. How does velocity relate to omega? The relationship is that V is equal to omega on K. Okay. So if you want to relate VK and omega, then omega will be equal to VK. Therefore, when you substitute this, you have A sine VKT minus KX. So you can pull out K. A sine KVT minus X. Knowing K to be equal to 2 pi on lambda, you can easily deduce that then K will be equal to 2 pi on 60. And this is pi on 30. Then Y will be equal to the amplitude, which is 0.2 sine of K, which is pi on 30. Okay. V is 360 minus X. This can be left as the progressive wave equation, or if you still want to play around this, you can push in K so that you have 0.2 sine of Okay, the zeros will cancel. So you have, and then 3 will go into 36, 12. 12 pi t minus pi on 30 x. So the equation can actually be this or this one. Okay. There's a lot of ways you can actually derive this equation. You can also go y is equal to a sine omega t minus ax. Then you look for omega. Okay. Omega, which is 2 pi f. Then based on what and what you have v, you have lambda. So f will be equal to v on lambda. 360 divided by 60, and this is 6. So you have y is equal to 0.2 sine of 6t 2 pi times 6. So 12 pi t minus, then you look for k. Okay, k we have already derived it as pi on 30. So pi on 30x. So there are actually a lot of ways to go around this. Please, any question? Amma?
Sir, please, what do you mean by wave number?
K, that is the letter representation is K. The number, okay, the number of complete waves that is channeled out within a particular time.
So, sir, please, can frequency be equal to K on, no, T on K? Or A? Yes. Can frequency be equal to K on T?
F, you said frequency can be equal to K on.
T. Can it be equal to K on T?
You can derive that. You can derive that. Okay.
Okay.
Question 2. Question 2. In a progressive wave given by y is equal to cos, this time the wave is given by the value of k. It is given in terms of cosine. Now, if it's in sine, your general wave equation must be written in sine. If it's in cosine, it must be as such, because I told you that simple harmonic function can be represented as a cosine or sine. Simple harmonic function can be represented as a cosine or sine. So you write your equation based on what it is given to you. Okay. So here we are to find it. So the amplitude and the frequency are respectively. So we have to determine the amplitude and frequency. So we derive one and then compare with it. So A cos omega t minus kx will be our general equation. Okay, so when you compare, the amplitude A is equal to 25. So you conclude, therefore, the amplitude is this. Then frequency omega is equal to 2 pi. So 2 pi f is equal to 2 pi. Therefore, f is equal to 1 hertz. That's just it. Okay. So you compare it with whatever is given to you. The equation can be a sine or can be a cosine. Then the third question. The displacement y of a wave traveling in the x direction is given by, so here x direction, it refers to positive x direction is given by y is equal to so our question 1 is even difficult than the NOVDEC question which came in under waves. Question 1 is more difficult than it. So y is equal to y is equal to 10 to the power negative 4 sine of 600t minus 2x plus power on 3, where x is expressed in meters, t in seconds. Then the speed of the wave in meter per second. Okay, so this, the angular, the phase difference between the origin and then a particular particle vibration is complex. It is not just 2x, but something being added. Okay, an angle of 60 degree or power on 3 radian added. Okay, so over here, power is complex, giving us 2x plus power on 3. So you just write an equation to represent it. So y is equal to a sine omega t minus kx plus phi. So we write an equation just to represent whatever we are given. So this is one way of going about this. Okay. The other way out, okay, so after writing this equation, you then go ahead to compare. So omega is equal to 600 and k is equal to 2. So if omega is equal to 600, then f would be equal to 600 over 2 pi. And 2 pi on lambda, 2 pi on lambda is equal to 2. Therefore, lambda will be equal to pi. If f is this, so f is 300 on pi. So if f is this, lambda is this, then v, which is f times lambda, will be equal to 300 on pi times pi, which is 300 meters per second. Or any way, whether it is starting from the origin or not starting from the origin, the speed is equal to omega on k, which is coefficient of t over the coefficient of x. And you see, v is equal to f times lambda. From omega, f is 2 pi, omega is 2 pi f. Therefore, f here is equal to omega on 2 pi. From wave number k, we have 2 pi over lambda. And so lambda is equal to 2 pi over k. So if you substitute f and this into the equation, you end up having V to be equal to omega on 2 pi times 2 pi on K. So that 2 pi will cancel out and you obtain this equation, omega on K. So this is how come we just based on this equation, make some terms, the subject, substitute into it to get this other equation for V. So we can also solve the same question by identifying omega, which is the coefficient of T, 600, and then K, which is the coefficient of X, which is 2. And we are there. So this is the second approach to the same question. Please, is there any question? If there is no question, then we move on to Eura. Marshall, are you there? Eura? Oh, Eura is gone. Adwa? Is your hand up or Priscilla?
No, please.
Okay. All right. Then let's move on to stationary waves. So this does it for progressive wave. Okay. I'll send you another set of questions on this. When it comes, just try. If you have any challenge, you can revert to me. Progressive wave. Still on the classification. We've done progressive wave. And the next classification we need to look at is stationary waves. I think we can finish this quickly and then begin a new topic. What is a stationary wave? Any idea? Let me throw it to the house. If you have any idea on stationary wave, share it. Okay, share that with us. Stationary waves. Stationary or standing waves. Or standing waves. Yes, anybody? Anybody? Amma, any idea? Charlotte, any idea? Kelvin, Festus. Okay. Tab, go ahead. Please, if your hand is up, go ahead.
Sir, please, a stationary wave is a wave that oscillates in a fixed position without moving in the direction of the wave.
Okay. All right. More views. If you have any other different description to on stationary, you can show that.
A stationary wave is a wave that is formed from the superimposition of two progressive waves that have the same amplitude and frequency, moving in opposite directions.
Okay, so more definitions. Okay. It's true. All that has been shared. Perfect. Johan and Bagwis, are you there?
Yes, sir.
Okay. All right. So all that has been shared. Perfect. But let's be practical and understand it. Okay. So it's stationary. Johan, mute yourself. All right. So why is it stationary? Meaning or standing at one place. Okay. Another definition, apart from all that has been said, is that about a stationary wave is that we define a stationary wave to be formed when two progressive waves, okay, of the same amplitude, of the same wavelength, of the same frequency interfere. Okay, so one must be coming from this end, the other must be coming from the, and they need to cross, interfere. Okay, this interference is what is termed as superimpose. So when two waves of the same amplitude, frequency, wavelength, but travel from opposite directions interfere, it creates a stationary wave or a standing wave. In this type of wave, energy is not propagated continuously within the medium, but the energy is limited, okay, or restricted within two boundaries. So instead of the energy being moving maybe from x, negative x to positive x, or from positive x to negative x continuously, the energy gets stuck within two barriers or boundaries. The reason for which we term it as standing, the energy stand, okay, and the particle vibration does not go in this manner. It's only oscillate or vibrate up and down between the two boundaries. So in progressive wave, the energy is propagated continuously within the medium. But in stationary or standing wave, the energy is restricted only within the two media or boundaries. So a stationary wave is formed when two progressive waves of the same amplitude, wavelength, and frequency interfere or superimpose when they travel from opposite directions. So it means that before a stationary wave will be formed, the two progressive waves must come from two different directions. Okay. Charlotte, mute yourself.
Oh, sorry.
Okay. So practically, how is it formed? And a practical application of this can be seen in guitar strings. Okay. The playing of string instruments such as guitar, violin, harp, okay, works on the principle of this. So for a stationary wave formed on the strings, guitar and then the string instrument, generally string instruments qualify for this. So practically, how is it formed? You see, if you've been very observant, okay, the guitar string is such that there is a boundary here. Then the string is connected from the boundary and then terminated at the other boundary. So barrier or boundary here, barrier at the other end. Okay. And in guitar string, there are usually 4 or 5 strings tied between two metals or boundaries. Okay. Now, when they are playing, they just plug this, cause this to vibrate. Once it vibrates, it creates resonance and then produces the sound. Okay. So in guitar strings, there are 2 boundaries. Then when the string is plugged or is made to vibrate, it creates a wave, one progressive wave. Then this progressive wave created as a result of the vibration hits the boundary or the barrier and then reflect. It's like water wave hitting the rocks at the seashore. So you see a return of the wave. So there's a reflection of the incident wave. However, the incident and then the reflection must have the same amplitude. Okay, so we have incident wave, then we have reflected wave. The crisscrossing of the 2 waves is what we are terming as they interfere or interference or superimposition. The crisscrossing of the 2. Okay, so over here we have 2 waves. One is moving in this direction and the other is moving in the opposite direction. This is the amplitude of the incident wave, and this is the amplitude of the reflected wave. They must have the same amplitude. Apart from they having the same amplitude, they must also have the same wavelength. Look at the wavelength. This is one complete wave, so 1.5 for the incident. Okay, and then the reflection. The reflected wave is also moving this way, also 1.5. Okay, so same wavelength and same frequency. So practically, that is how a stationary wave is created. Please, any question? Any question? All right. So basically, all that we are saying is that you can form a stationary wave from a progressive wave. You see, for a progressive wave, there is only a single barrier. So if the wave starts from this end, then when you disturb this medium, when you disturb the medium, you create a progressive wave around it. Now, you can form a stationary wave when you create a barrier within the huge medium. So in a progressive wave, the medium is large, big. But if you could shorten the medium by creating a barrier, so if it's the ocean, then I can, when I decide to build a wall within, the ocean wave comes, hit it, and then reflect, creating a stationary wave. So you can create a stationary wave from a progressive wave when you create a boundary. So whenever you create a boundary, you shorten the medium, the length of the medium. And so the wave would go, hit the boundary created, and then reflect, creating a stationary wave. Okay, and in this case, you see, in the case of this, the particles will just vibrate up and down in between. Instead of it traveling this way, because you've created a boundary, the particles will not vibrate in this direction. They will only wiggle up and down, okay, within the boundary created. And so the wave will not travel in this direction, horizontal direction, but will just travel back and forth, up and down within the boundary. That is why we say that the wave is standing. It only stands between the two boundaries and does not and it's not propagated horizontally. All right, please, is there any question? Okay, then let's move on to features of stationary wave. Features. You know, for progressive waves, the features noticed are that there is a point of maximum particle vibration upwardly, and there's a point of maximum particle vibration but downward. So a progressive wave has crests and troughs. In a progressive wave, the energy is propagated continuously throughout or within the medium. What other characteristics does this one also have? For a stationary wave, we have what we call crests and troughs. We have crests and then troughs. Whenever you are drawing this, you must check the amplitude of the incident and then the reflected. They must be the same. So you must draw it with some swag, else you only draw a rope. So incident, then in most books, the reflected wave is represented as a broken line. Whether broken line or unbroken, the value is still the same. There is a point where particles are not vibrating at all, zero vibration of particles. So that their displacement along the y axis is zero. And these points are termed nodes. N. So this endpoint are termed nodes. Nodes, N-O-D-E-S. Then there is also a point of maximum particle vibration. You see, if we look at a particle vibrating, and this is the equilibrium position, when there's no disturbance to the medium. When there is disturbance, this is it. The particle can vibrate to this point, this point, this point. So the maximum particle vibration will be somewhere here and here. Okay. The point of maximum particle vibration is what we are terming as antinodes. So the AAA point are a point where particles have maximum vibration. And in physics, this is termed as antinodes. Antinodes. A. So a progressive wave Okay, in a progressive wave, there are crests and troughs, whereas in a stationary wave, there are nodes and antinodes. Charlotte, what did I say? Charlotte, what did I say?
Yes, they did. Unless you come again.
Hey, you see, Johan, what did I say? Johan, what did I say? Okay, free will. Can anybody share with us what I just said? Yeah, anybody? Abba,
So please, you said in progressive waves we have the crest and the troughs, and in stationary waves we have the nodes and the antinodes.
thank you. Abba, thank you. Charlotte, you must pay attention.
Yes, please.
Now, how are they formed? How are nodes and antinodes formed? We have one progressive wave from left to right or towards the positive x-axis. Then let me create the boundary here. I'm just creating something for explanation's sake. Then hit this boundary and then reflect. So just pardon me, I'm not adding aesthetics to my drawing. So now, as the incident wave, this is the reflected wave. As they travel, there will be a point where the two waves, incident and then reflection, would align themselves so that their individual amplitudes will be in phase, will be at the same angle. So let's assume during the reflection, you see this amplitude and this amplitude of the two waves met at the same angle. And so their nature became something like this. They met or coincided, and their individual amplitudes. There's the amplitude of this, and then there's the amplitude of this one, even though the amplitude must be the same, but we are not adding aesthetics to the drawing. So when the two waves meet in this manner so that their individual amplitudes occur at the same angle, an antinode is formed right there. An antinode is formed right there. Okay.
Please, can you come again?
So when the two waves, as they travel, when they align themselves in such a way that their individual amplitude align or are at the same angle, or they come in phase, you see, because the individual amplitudes are aligning themselves so well, if we want to determine the overall amplitude of the incident and then reflected wave, it is A plus A, and we'll have a larger amplitude 2A at that point. Then The waves can also align in such a way that the individual amplitudes of the two would cancel out. So this is a typical example. Look at where the incident wave, where this amplitude is, and then the reflected wave during the reflection. So when we look at this one and then this one, they are not meeting at the same angle. Okay, so the incident and then reflected can meet in such a way that the two waves may meet to add their amplitude, or the two waves can disconnect. Their angles will be different. Okay, and when their angles are different, we say that the two waves are out of phase. In that case, because one amplitude is at the upper part of the wave and the other amplitude is below, we'll have a situation where when you add their amplitudes, you have A plus minus A. The two amplitude in this case will cancel out to be 0, and at that point, a node will be formed there. So how nodes and antinodes are formed is this. Antinodes are formed as a result of the constructive interference of the two waves. And when two waves interfere constructively, their individual amplitudes add up to form a larger amplitude. So antinodes are formed due to the constructive interference of the two waves. Okay, and when two waves interfere constructively, we say that the two waves are in phase and their individual amplitude add up to form a larger amplitude. Amma, what did I say? Amma, go ahead.
I have to ask a question. Well, okay. You said antinode is the constructive component of the same amplitude. And so I wanted to ask that since one of the amplitude is positive and the other is negative and they cancel out, why do we still get a bigger amplitude?
No, I'm talking about a situation where the two waves, incident and the two reflected waves, are aligning as this, so that their individual amplitudes, okay, can join to form a larger amplitude. And I'm also looking at a situation where let's assume this is one amplitude of this, and then this is another. It may not be exactly as what I've drawn, but another amplitude, the amplitude of the other wave is also this. In this case, this is the amplitude of one wave up here, and this is also the amplitude of the other wave, which is down here. So when you add, they cancel out to form a 0 amplitude. Okay, so in the formation of antinodes, we said the two waves must align themselves constructively, okay, in constructive interference. And when waves are in constructive interference, the two waves are said to be in phase, and their individual amplitudes add up to form a larger amplitude.
Okay.
So let me give you that statement quickly. So antinodes are formed due to the due to the constructive interference of the incident and reflected waves. And when waves interfere constructively, they are said to be in phase. Don't forget, when two particles are said to be in phase, then it means that they occur at the same angle. Okay. At the same angle. They are said to be in phase, and their individual amplitudes add up to form a larger amplitude. So antinodes are formed due to the constructive interference of the two waves. And the two waves here, we are referring to the incident and then the reflected waves. Then nodes. Nodes are formed due to the destructive interference I think this is E. Interference of the incident and the reflected waves. And when waves interfere destructively, they are said to be out of phase, The two waves, when they interfere destructively, are said to be out of phase, meaning at different angles, okay, at different angles. Okay, at different angles. And their individual amplitudes cancel out. Amplitudes cancel out. So when AA, when they cancel out, it will be 0. It will be 0. Please, is there any other question? Amma, Charlotte.
Please.
Let me quickly take your attendance and then get back to you. For a progressive wave, that is considering one of them, this is a wavelength, lambda. This is lambda. When the shape, if the wave forms a shape like this, we have a full wave, lambda. Meaning that if this is lambda, then from node to node, this wavelength or this length of the wave, this will be equal to what? If this is lambda, what will be this wavelength? From node to node. Yes. Abba. Abba, if this is lambda, what will be this? Let's not waste time.
Half lambda.
So this will be half lambda. Now what about from one? Okay, before we talk about from node to node, consecutive nodes, the wavelength is equal to half lambda. Now what about this distance from a node to antinode? This distance, what will be this wavelength? From node to, pardon?
1/4 of lambda.
So from node to antinode or antinode to node, the wavelength is quarter lambda. So from node to antinode, quarter lambda, or antinode to node, the same thing. Then from node to node, that is successive or consecutive nodes. Successive or consecutive nodes. If from consecutive nodes is half lambda, what about consecutive antinodes? What about this distance? From consecutive antinodes, what will be the distance? The same thing, we have consecutive antinodes here. Yes.
1.
Pardon?
1.
Lizzie, open your eyes. Oh.
Half.
From node to node, we have half lambda. From node to antinode or antinode to node, the same half lambda. So what about from antinode to antinode? Please calculate well.
Half.
3 on 2.
Pardon?
3 on 2.
3 on 2. So somebody is saying 3 on 2. I heard somebody also saying half lambda.
It was little said 3 on 2.
3 on 2. Okay. Any other view from antinode to antinode? Any other view before I come in? Okay, let's look at it. This is node. sorry, antinode. Another antinode. Already we are saying that from antinode to node, this is quarter. This is quarter lambda. From node to antinode, another quarter. So it means that from antinode to for successive antinode, it is also half lambda, because quarter plus quarter, half. Lizzie and Co, are you okay? Lizzie,
Yes, yeah.
are you okay?
Yes, please.
And these things must be at your fingertips. It must actually be at your fingertips. I'm coming. Okay, you must understand that when you see a full wave, in fact, as for that, you must be able to see. We've gone through waves. This is a full wave, and the length of a full wave is lambda. So if we have half of the full wave, which is node to node, is half lambda. Then node to antinode or antinode to node, quarter lambda. Okay, so note that the wavelength from node to node, half lambda, antinode to antinode, half lambda, but node to antinode or antinode to node is quarter lambda. And in our journey of stationary waves, we are going to apply this so much. So these 4 wavelengths must be at your fingertips. Please, any question? Any question? Amma, Charlotte. Yaba, are you there? Okay, Amma.
So, sir, how then do we define the wavelength of stationary wave?
Pardon?
How then should we define wavelength of a stationary wave?
Oh, it's not different from progressive wave. Okay, so just the distance between 2 consecutive or successive points that are in phase. The real. Here,
But sir,
I'm listening.
But sir, you are saying the stationary wave between 2 consecutive antinode or node, it is half of the wavelength.
So basically,
And
let me cut you short. It means you can use the definition of the distance between 2 successive crest and trough. No. Okay. So just the distance between 2 successive points that are in phase. It's not wavelength in progressive wave is not different from stationary wave. All right. Then let's look at the almighty stationary wave equation. Stationary wave equation. Yaba. Oh, Yaba is not here. So, you see, for a stationary wave, we have 2 progressive waves, one incidenting, the other reflecting. So this wave, the incident wave, has an amplitude A. And then the reflected wave, which is this. Also has an amplitude A. You know, amplitude must be the same. So if we look at the whole stationary wave, the amplitude Y would be equal to 2A. So if we are talking about amplitude, it will be of the stationary wave is this. But the amplitude of the progressive wave must be small a. So twice the amplitude of the progressive waves would give you the amplitude of the stationary wave. So equation of a stationary wave. For a stationary wave, we have two progressive waves, one in this direction, the other in the opposite direction. So Y1, the incident wave, has an equation given by A sine, and because it is moving from left to right or towards the negative x, this is equal to omega t minus kx. Then this is the incident wave. Equation of the incident wave. Then the reflected wave. Yes. I want somebody to help me to write an equation for the reflected wave. The gentlemen are not in the house. You are not in the building. Let me look for them. Kelvin, you are here. And Festus. Doku, you are here. Okay. Festus, what do you think will be the equation for the reflected wave?
The A sine omega t plus kx.
So A sine omega t plus kx. Thank you. Plus because it is moving from right to left. And this will be the equation of the reflected wave. And when they superimpose or interfere, the equation of the two, whether small y or big Y, will be y1 plus y2. So this is equal to A sine omega t minus kx plus A sine omega t plus kx. This is the equation of the stationary wave when they superimpose. Now I want you to simplify this for me. So we can pull A out. A here, A there. So A out, sine omega t minus kx plus sine omega t plus kx. I want you to simplify what is in the bracket for me. So 2 minutes, think through it and simplify it for the bill for us. 2 minutes. Use addition of trig function, trigonometric function to add this 2 within 2 minutes. Start work. whilst I check attendance. So Abba is here, Ajua, Abdumajima, Ekuya. Ekuya, these days you are quiet and I don't like it. Amma, Annalyn, Alvina, Eura, I've been calling you. Festus, Henrietta, Jeriel, Calvin, Lizzie, Lois, okay, Lois, Maltiti, Na, hey, Kirsten, Nana, Nathania, Othniel, Samuela, Stephanie, Tuchi, Yaba. So Yaba, you are here. Yaba. Are we done? Samuel, are you done? Stephanie, are
No,
you done?
please.
Stephanie, Festus, Calvin, Doku, Othniel, Tucci. So 1 minute more.
Okay. So please, so the first part, sign one WT minus KX is equal to sine omega T cos KX.
Plus KX.
This is it.
I can sign omega T plus KX.
No, the sine omega T minus KX is equal to sine omega T cos KX minus cos omega T sine KX.
I'm interested in the final results you had. When the
I
final
got
Mm.
2 sine omega KX.
2 sine.
Omega T cos KX.
Okay. Yes. Who else managed to finish? Who else finished? I want to see what you had before we go through together. Lizzie, did you finish? Stephanie, did you finish? Ekuya Watima, Calvin, Festus.
Yes.
Okay. So, for the benefit of all of us, let's go through this. So, the bone of contention is all about simplifying what we have within the brackets. So, sine of omega T minus kx plus sine of omega T plus kx. Okay. Now, if you have sine A minus B, here omega T and kx represent 2 different angles. So it's like addition of compound angle. So if I have sine A minus B, the expansion of this is sine A times cos B minus sine B times cos A. So the expansion of this one will also be sine omega t times cos of the other angle, which is kx, minus sine of, then the interchange angle. Earlier I was sine omega t. So sine will take kx. Kx times cos of omega t. So this becomes the expansion of this. Now plus the expansion of sine omega t plus the same rule, but the only difference is that this time the operator, the separating will be plus. So sine omega t times cos kx plus sine, then the interchange angle kx times cos of omega t. Then we add them. We add like terms. Sine kx cos omega t minus. We also have sine kx cos omega t positive. So this and this would cancel out to be 0. Then this is sine omega t cos kx positive, sine omega t cos kx positive. So we have 2 sine omega t cos of kx. So this becomes the expansion of whatever we have within the brackets. Okay. So times 2 sine omega t cos kx. So the progressive wave, the equation of the stationary wave becomes 2a cos kx sine omega t. This is the equation of the progressive wave. Please, any question? Well, you see, when we compare this to a progressive wave would have y is equal to a either sine omega t or cos omega t. A is the amplitude of the progressive wave. Over here, 2a cos kx becomes the amplitude. So the amplitude itself is a trigonometric function. Okay, so 2a cos kx is the amplitude of the progressive wave. So the amplitude of the stationary wave is equal to 2a cos kx. 2a cos kx is the amplitude of the whole stationary wave. So over here, the amplitude is not just a number, it's a trig function. Meaning that once it's a trig function, it means that different angles must give you different values of amplitude. Okay, but in all, the general amplitude, the amplitude of the stationary wave must be either plus 2a or minus 2a. But different angles, you see, over here, for a progressive wave, the amplitude is always either plus a or minus a. But over here, for a stationary wave, because it's an interference of two, okay, different angles will certainly give you different values of amplitude. Unlike here, where it can just be one time read, one situation, and you can determine the amplitude from the graph. But over here, because the amplitude is a trig function, different angles would give you different values of, or it would give you the amplitude, the same amplitude, but the amplitude would occur at different angles because this is a trig function. Please, any question? Class, any question? All right. Then let's use the stationary wave equation to determine point where nodes and antinodes will be formed. Let's use the stationary wave equation to determine points where nodes and antinodes will be formed. This one is understandable, but you must pay attention and ask questions. So, are you there? Charlotte, are you there?
Yes, please.
Festus, Calvin, and Co. be asking questions. So we just realize that the equation of the stationary wave is given by 2a cos kx sine omega t. And the amplitude A, or amplitude is 2a cos kx. And this amplitude would always be equal to plus or minus 2a. Plus or minus 2a, meaning it is always two times the amplitude of the progressive wave. Okay? Always two times the amplitude of the progressive wave, because we are looking at a wave moving, hitting the boundary, a progressive wave of an amplitude this, and then an amplitude this. Then when it reflects, hits the boundary and reflects, we have the amplitude of the progressive wave being equal to from antinode to antinode. So it is either 2a plus 2a or minus 2a. Okay? When you are measuring from here, from below 2a, from up down minus 2a. Okay, so it's always twice the amplitude of the progressive wave. Now, if the amplitude is this, we want to determine point where nodes, angles. I earlier said that the amplitude occurs at different angles. So we want angles where an amplitude, a node and an antinode will be formed. Okay, that when you identify a node, you have had an amplitude. When you identify a node, sorry, let me take it again. When you identify an antinode, it is equal to the amplitude of the stationary wave. When you identify a node, it is equal to 0 amplitude. Let me draw it again and then explain. This is a progressive wave. Reflection to create it. Hey, this stationary wave is nasty. A. So when I identify angles where antinodes are formed, it means that position must be equal to the amplitude. When I identify points where nodes are formed, it is also equal to an amplitude of 0, because a node is just on the horizontal equilibrium position. And at that point, amplitude, which is maximum displacement of particle, is 0. Okay, so identifying an antinode identifies the amplitude of the whole stationary wave. When you identify angles or points where nodes will be formed, the amplitude is 0. Class, are you okay? Are you okay?
Yes.
Please come again.
Identifying antinodes is equal to identifying the amplitude of the stationary wave. Okay. Then identifying nodes, the amplitude or the displacement of the particle there is 0. So antinodes correspond to amplitude, whereas nodes also correspond to 0 displacement. Now, I'm teaching you this because you can be given a stationary wave equation, and then because a stationary wave is characterized by nodes and antinodes, you will be asked to determine points where nodes and antinodes will be formed using the stationary wave equation. Okay, so assuming you are given an equation, a stationary wave equation, and your task is that determine points where nodes and antinodes are formed. So you are given the equation y is equal to this, and the question is that determine points where nodes and antinodes are formed. And once this is an equation of a stationary wave, it means there are nodes and antinodes. So you must be able to do this. How do we do it? When you take the amplitude, let me use this as big Y and use small y as the amplitude function 2a cos kx. Now, class, if I calculate this and then the amplitude is equal to 0, what does it mean? If I calculate for the amplitude and I get the amplitude being equal to 0, what does it mean? Any idea? If the amplitude... Charlotte, I'm listening.
Then it's a node.
Yes. It's a point of no vibration of particle, a node. Okay. So a node will be formed when 2a cos kx is equal to 0. 2a cos kx is the amplitude function. Okay. But don't forget, kx is just like theta. Okay. Kx is just like theta. So we are looking at the angles, the different angles where the amplitude will be equal to 0. Okay. So cos kx is equal to 0. Yes. If we divide through by 2a, we'll have cos kx being equal to 0. But at what different angles are we going to have kx cos kx being equal to 0? At what angles? So kx will be equal to 0 at different angles. But what different angles in a harmonic function would give us the cos function being equal to 0? Yes, Emma.
Yeah, cos 90.
So 90 is one of them. But since this is a harmonic function, we want to change our angles to radians. So we want to change. Okay, Emma is saying that 90 will be one possible angle where cos will be 0, and it's true. But I want to change this angle in degree to radian. So change 90 degrees to radian for me. That will be
I.
Okay.
it's pi on 2. What other angles again can cos be 0? Apart from 90, what other angles would cause? Please don't forget, this is a harmonic function, a continuous function, which hits a boundary. So there can be more than one angle. I'm gonna go ahead.
270 degrees.
So yes, cos. Did you say 270?
Yes.
So cos 270 would also be 0. But change 270 to radian for me.
Three on 2 pi.
Okay, so we have kx is equal to pi on 2. Is that 3 on 2 pi?
Yes, please.
Do we have any apart from these two? Apart from these two, do we have any? Cos what again will give us an angle of 0? Oh, last one. 90, 270. I'm waiting. Let's not waste time.
Sir, please, what of please, what of 180? Can it be included?
Because 180 is -1. Please use your calculators to check. Is that 90? The next is 270. What's the difference between this? Difference between 90 and 270.
180.
So the next one is I add 180 to this.
Okay. 150.
So point cos of that, and let's see if that will not give you 0.
Please, it gives 0.
Okay, so change that to radian for me.
So that is 5 on 2 pi.
So 5 on 2 pi. On and on and on. We can have it, okay? Meaning that these are the various angles where the amplitude will be 0. So we can obtain nodes at these angles, okay? When pi is 90 and when theta is 90, we'll have a formation of node there. When theta is 270, when theta is equal to, when you added it, you had what? Forward. When you added 180 to that, what did you get? So
450.
Okay, 450. So meaning 450 would also give you a point where node will be formed. But that is not all. It can be on and on because this is a continuous function. Okay. So to help easy memorization of this, you see, the angles follow a certain pattern. Pi on 2, 3 pi on 2, 5 pi on 2. The next will be 7 pi on 2. So the angles where nodes will be formed are actually 3. We want to write a general formula for it. 2n minus 1 on 2 pi. So that when n is 1, you have pi on 2. When n is 2, you have 3 pi on 2. When n is 3, you have 5 pi on 2. When n is 4, you have 7 pi on 2. So these are the various n angles where nodes will be formed. Okay. Kx. Is that okay? Then, you know, k is equal to 2 pi over lambda x. Okay. This and this can cancel out. So we want to, out of this equation, we want to make n the subject. And x. Pi is canceling out. So 2n minus 1 all on 2. Help me make x the subject from what we've had. Help me make x the subject here. Charlotte, what will be x? From this equation, what will be x?
X will be equal to 2n minus 1 all brackets lambda.
2n minus 1.
Yeah, lambda.
Lambda. Okay. Because the 2 would cancel out. All right. So please, what it means is that if I want points where nodes will be formed, okay, 1, if n is equal to 1, then it means that if n is equal to 1, it means x will be equal to lambda. If I determine x is equal to lambda, a node will be formed at that point. For n is equal to 2, then for n is equal to 2, we'll have 3 lambda. At 3 lambda, a node will be formed. If n is equal to 3, 5 lambda, a node will be formed on and on and on. So identifying X gives you point where nodes will be formed. Amma,
Sir, please, how would the two cancel out?
open your eyes very well. We have 2x over lambda. So when you cross multiply and make lambda the x the subject. Oh, it won't cancel out. Charlotte, it will multiply rather.
Yes, please.
Amma, thank you. Let's go through it and then see it. So we are making x the subject. Okay, lambda par cancelled out is gone. So x will be equal to 2n minus 1 on 2 times lambda. Okay, also divided by 2. And so it will be 2n minus 1 on 4 lambda rather. Amma, thank you. Okay, so it means that when n is equal to 1, we'll have x being equal to quarter lambda. So at quarter lambda, a node will be formed there. For n is equal to 2, it means at 3/4 lambda, a node will be formed there. Fifth lambda on 4, on and on and on. So these are different points or positions where a node will be formed there. So identifying X, okay, identifies points where nodes will be formed on and on and on. We'll solve questions, and so you understand how this works. Let's go through the theory. Then quickly, let's look at points where antinodes will be formed. Point where antinodes will be formed. We have barely 6 minutes to go. So tomorrow I want us to quickly do this and do something else. So now antinodes will be formed when this part, when cos kx is equal to 1. Because when this part is equal to 1, we'll have 2a. So y, which is the amplitude function, must be equal to 2a cos of kx, and cos kx must be equal to 1. Now, for cos kx to be equal to 1, what different angles will give us a situation where cos kx is 1? What different angles? So it means the angle kx must be equal to, yes, give me the angles where cos kx is equal to 1.
0.
So when cos 0 is equal to 1, so 0,
180.
180. So 180 is pi.
No.
Sorry. It's not 1, but a plus or minus 1.
Okay.
When cos kx is plus or minus 1, we'll have plus 2a or minus 2a. So 0 pi
360.
is cos 360. Is it 1?
Yes, please.
And 360 is equal to
2 pi.
2 pi. Then it's obvious. The next one will be 3 pi. On and on and on. So we can write an n equation for it. It means the angles must be n pi, isn't it? When n is 0, we
Yes,
have this.
please.
When n is 1, we have pi. When n is 2, we have this. On and on and on. So for formation of antinodes, the angles must be n of pi. Now, if this is it, then what x values will give us this? So 2 pi on lambda x. Pi will cancel pi, and x will be equal to, yes, what will be the value of x? What is the value of x here? So let's hurry up. Am I and co
N lambda on 2.
n lambda on 2. Meaning so the x values expressed as pi or lambda gives you the different point where, so these are points where an antinode is formed. Meaning that when n is 1, an antinode will be formed at half lambda. Meaning n1 implies that the first formation of antinode or node. N2, the second point where an antinode will be formed will be equal to lambda. The third formation of antinode will be 3 lambda on 2. The fourth position will be 2 lambda, on and on and on. So these are points where antinodes are formed and points where nodes must be formed. The whole idea is that you identify the angles where nodes and antinodes will be formed and the rest. So we'll apply this in solving questions tomorrow. Okay, by solving questions, I'm sure that the conceptual understanding of this will be clear. So we'll continue tomorrow. Please take care of yourselves and then have a fruitful day. Bye-bye.
Please don't end the class.
Okay.
Thank you.
Charlotte, you let me know when you finish.
Yes, please.